Start recording. Okay, guys. Welcome back. For some of you in strengths, we're starting with electrotechnology. Yeah, this subject is a continuation of electrotechnology 1, but what will happen is we will move from solely DC circuit analysis to AC. So we're analyzing a lot of AC circuits. And it also forms the basis for Electrotechnology 3, which is one of the more challenging in the marine engineering diploma. Anyway, just my introduction. I've shown you guys myself already. I can move on from this. Discuss lectures, exactly the same setup as before, nothing new. And yes, so prescribed textbooks for this particular subject. We'll be using Electrotechnology 2 for technicians. It's for technicians, it's called Electrotechnology 2 actually. It's also on the Bravo campus, also around 140 copies. And we're using another textbook called John Bird. Now, the reason why I prefer John Bird is a textbook, but it's quite expensive. So, and we normally use this textbook anyway for Literature 2, but I'll use a lot of things from John Bird, as well as Reed's Volume 6. So, both three books over here is what I essentially use for a lot of examples. I mean, what's important here is, of course, the prescribed textbook's the main one, and you can definitely supplement John Bird. And the Reed's has good examples as well. So is everyone familiar with these textbooks? Does anyone have them currently? Can I just see? Hello, students. Not yet. Okay. So these are textbooks you're going to need. Is anyone familiar with these? So this is the tools you basically need. And of course, your Casio calculator, which I mentioned. I have the file link. Okay, great. Yeah. So some of you guys have the textbook already. That's great. I'm looking for something. Now. I got elected too. Okay, great. I know most students share the textbook, so that's why it's my question with regards to that. I just want to check something quickly. Just coming to me now. Right. Okay. I think let's move on. Just quickly see something. Okay. Right. So we're going to get right into this. Things we'll be covering. That's for this particular subject. We're looking at basic electrical calculations. It's essentially a bit of revision with a touch of a new analysis on the C. Additional C is a mistake. Basically, some all the important parts of lectures 1, which you kind of need. The second thing, we're looking at DC circuit analysis and theorems. So we'll take 2 weeks for that. So we're looking at different theorems on how to solve circuits. So we've got Kirchhoff, which you're familiar. It's actually a law. We've got superposition theorem. We've got Thevenin. We've got Norton. We might look at mesh. We might look at nodal. There's a few techniques we will look at. Then we were looking at energy, and I'll try to make that particular part interesting. Small chapter, but I'll be kind of relating to a maritime perspective. It's also within the textbook as well. Then we're looking at AC current. That's where we start actually looking at what is AC current, how it's generated, and all that. And after that, we'll start looking at AC circuits. So instead of DC, we start looking at AC circuits. From AC circuits, we look at resonance. What is resonance? You learn about, in fact, from AC circuits, you learn about capacitors, inductors, things of that nature. In resistors, you put them in a circuit, current will behave in particular ways. Then we look at a very important concept called power factor, which talks, it's a very important thing for electrical supply and generation. Then we get three phase, that'll form the fundamentals for electrodes 3. And we will look at DC machines, particularly motors and generators. We end off again with DC. What might be here, which is not on here, is also we might look at wiring, cabling, and transformers. That's two more sections which might not be on here. Let me just see one. There's 1, 2, 3, 4, 5, 6, almost 6, 7, 8 sections of work to cover. But we'll see how it goes in terms of how we progress. Okay, the next is messages over here. I got outside messages, and then after this, we've got our assessments. Again, I'm going to keep it to tests. Because we're not that much, so 2 tests will be suffice for us. That's going to be easy to kind of conduct, and you probably write the electros test, I'm assuming, on the Monday or Tuesday towards the end of March, because our term dates, the term ends on 31st of March. So there's a week, the last week, I think, allocating end. Of course, you got 2 tests in FISA. And of course, I didn't mention strengths, but the same electrodes, term 1, test 1 will cover all the work which we covered in the term. So, but no, whatever chapters we cover, and test 2 will be in a similar fashion where we cover all the work in term 2, you write test 2. I normally have my test 2 before the study week, so guys have adequate time to kind of prepare for that. Then again, it's the same as before. There's nothing additional in terms of what's expected of you. It's exactly the same as the materials. Don't know talk too much about this, but your schedule, your study schedule, 3 to 4 hours a day is really critical. And make sure you complete all the exercises, whatever past papers I post, tutorials, additional things, just to get yourself busy. Okay, so that's a blank slide, and now we can just basically recap on, we can start an official lecture now. So if you have your textbook, you can open it up, chapter 1. Just a slight recap with a bit of some numerical examples to get your blood flowing for Electrotech. Right. So what is a circuit? I'm sure you've seen this, and of course I'm showing you a fairly complex thing over here. But within the circuit is particular elements which is very common over here. Like we have this coil, if you remember, it's called inductor. Got a resistor, you've got a capacitor, and you have 2 coils next to each other. It's a transformer, and we have all these complicated ways of arranging this. So what is a circuit, right? So a circuit is an electrical circuit set of various elements, right, connected in a certain way, through which electrical current can pass. And of course, these elements I'm talking about is resistance, capacitance, and inductance. And we'll go into a bit of what that is. It's very theoretical based, but we will be analyzing a lot of this, especially in the nature of AC. Just some terminologies to kind of recap. Again, it's a closed loop consisting of several conductors connecting. Yeah, of course. So it is a wire, which you call a conductor, normally copper. Do you guys perhaps know on who has been on C? What kind of cables are you guys using on C? Can anyone give me a Give me some insight on that.
Yeah, we get copper and aluminium.
Thank you. Normally copper and aluminium, right? That's the kind of conductors we use. I'm just thinking of something here. Okay, that's fine. Okay, so and then of course, and there's also something called a switch, which basically they interrupt conductors with the current flow. And you can see that's how it looks. Not just they're just basically showing some basic circuits. Very important, very important. Who is aware of how does current flow? Who is aware of conventional current flow and electron flow? Does current flow from positive to negative or negative to positive? Can we have a discussion around this? What do you guys remember? Can we talk about this? How does current flow? Does anyone have an idea? Hello? Positive to negative? Let's have a look. Oh, wait. Yeah, but I think physically it's electrons that move, but we might. So you see, so it's fantastic, fantastic, fantastic. So initially, scientists thought that it flows from positive to negative, right? Um, why is this looking so confusing? So I'm looking at this positive to negative. Yeah, yes, makes sense actually, right? But that's not true. But physically, as it says, or actually, what actually happens is that the electrons are actually flowing, right? And they flow from negative to positive, and that has to do with the positive charged particles or negatively charged particles. So what we use for our analysis is still the standard positive to negative. It doesn't make a big difference actually. It does in terms of current flows and things like that. But we are adopting the conventional current, not the electron flow. Of course, the electron flow is the correct way, which whereas the negative side has more charges than the positive side, and kind of that's how it flows. So we are dealing with um, conventional current flow, positive to negative, guys. Very important. Okay, yeah, so you did say the positive side of the source attracts electrons and the negative side releases electrons. So that's we could say the negative side is basically this positive charge. So standard convention assumes that positive charge flows in the direction opposite from the electrons. Current describes the flow of this positive charge, not electrons. So we owe this convention to Benjamin Franklin, who thought current was the result of motion of positive charge particles. That's just a touch on the conventional and conventional current and electron flow. Another important thing, saying a load consists of a network of circuit elements that may dissipate or store electrical energy. Not a big deal to worry about that. It's important here is to note the ground and what is a ground, students? Who's familiar with the ground? What is a ground for? Is the protection device? Anyone have a point? Ever have some? Does even have any idea about the ground? Students?
So what I know about the ground is used for protection as it has a lower resistance, and if we have a, how can I say, a bypass of current, it goes straight to the ground.
Fantastic, fantastic. That's what it's for. Thank you. That is very, very good, very well presented. It's also we also use a ground. Oh, it indicates a reference point to where voltage is measured. That's another one, but it's mainly for protection. And the guys on sea, where is the ground on a ship? Is it the water? Can someone perhaps tell me?
It's the hull of the ship.
Oh, on the ship. That's correct. Yes.
Ship's hull, yeah.
Yeah. So
That's correct.
that's very important. So I was just checking. Okay, good. So that's what the grounds also should always be on a circuit, by the way. Okay, so where are we here? Circuits and terminology. So this is just about some terminology about the reference voltage is at ground potential or zero potential. No, that's fine. There's more terminologies in terms of what is ground voltage and things like that. It's not too much to touch on. Also other common ways of showing the ground. In the case of depending whether you're doing hardcore electrical or electronics, you've got the chassis, you've got the earth, and you've got the analog and digital. Just different ways of portraying. I want to show you guys some interesting software, which I let the previous guys do, but you'll be using the software more for enrichment purposes. Of course, it's just more symbols, which is also important. You know, you've got your conductor. I'm sure you've seen this before. A fixed resistor, variable resistor, so we can change the current flow. A cell, which normally has a voltage, and maybe you have a battery of 3 cells connected maybe in series. Switch, filament lamp, or fuse, an ammeter, voltmeter, and alternate fuse or symbol. So just a few, just in case we can, these electrical diagrams. These are very important to note. Okay, next. Okay, so now we can finally go on circuits, right? So circuits. I'm not going to talk too much with all the words, but you know, say they all have one common terminal, one terminal in common. One lead is connected to another lead, right? And a common point between the two elements is not connected to another current carrying element. But the point is, you see in the series circuit, right? You've got a voltage source, maybe a generator. Of course, and it provides the current flow from positive to negative in our case through those resistors. You guys should know, of course, in the series circuit, the current is the same in all parts, right? But the voltages we have to add algebraically, so the total sum of the voltages. And this is just basically doing Ohm's law and showing the resistance, or in a similar fashion, we have to add each resistance together. Of course, you guys are aware of that. So, what I would like you guys to do, right? They say determine the battery voltage V, right? The total resistance of the circuit, and the values of the resistance. Given that the potential differences across R1, R2, R3, R5, 2, and 6. So how are you going to find, and I'll give you, of course, the total current over there on the diagram. So let me get those. Can someone give me the voltage quickly? Who is smart here? It's very simple questions. Like I said, just to warm you up. Very basic stuff. Okay, where's this? 13 volts. Was it 13? 5, 2, and 6. That's 13 volts. That is correct, right? So that's obviously we just add all the voltages. And then the next question is, what's the total resistance of the circuit? You can work that out. Ohm's law, guys, very basic. .25. So how do we get that, guys? That should of course be 13 divided by 4. And then we have, that'll give us the total resistance of 3.25. Okay, so then they want the individual what is it? The individual values of the resistors. Got the total current, you got the total voltage. Let's see who's still sharp here. Does anyone have an idea? Remember, you have the current and you have the voltage. Let's quickly see for R1. R1 is 5 volts divided by 4, 1.25 amps. That is correct. Oh, sorry, ohms. Yes. We're going to say 2 divided by 4, which will give us 0.5. Of course, I'm not doing it because it's so elementary. And then we're going to have number 6 divided by 4. That's going to give us 1.5. Does anyone agree R3 is 1.5? Oh, you got, that's the next one. Fantastic. Okay, guys, so just some few basics to get yourself moving. Another question over here. But before we, so I'm assuming we all know how to solve CD circuits. So I'm not, it's not really a big deal over here. So what we will do, I want to show you a new technique called voltage divider rule, the VDR. It's also called, let me just check something. So it's a very handy technique when you're dealing with where is it? It's called a voltage division. Sorry, yeah, it's voltage divider voltage division, right? And so what it essentially is here, I'm going to show you. So I'm not going to particularly do the example. You can do it on your own. You just have to find the resistance 3, and of course you can just kind of work around. This is kind of a crux of what I want to show you today. So how voltage division works is like this. So it's a new technique. Treat this as a new technique on how to solve circuits. So what we have here is a circuit, a CD circuit, and voltage division is only applicable to CD circuits. So I'm gonna make you guys aware of that. So you've got 4 resistors, 7, 5, 12, and 15. You've got a voltage source of 110 volts. So this voltage divider rule, what it does, if you want to find the individual, if you want to find, so you can see these voltmeters over here, and you want to find the individual voltage across these resistors. So of course, normally you do that, you're going to first find the current, if you agree with me, and then afterwards you'll start dividing out. But one way to do it, and in the previous slide, they essentially show you the kind of the derivation of what's actually happening here. But of course, we don't have to really go through that. Is that what we do? We take the source voltage. So let's say we're going to find the volt across V1. I'll just do it here. So what we're going to take is the source voltage, which is 110, times it by the resistor which we want. I'll say that again, times it by the resistor which we want. 7. We divide that out, and then we're going to say, then we have to tally all the resistors over here. So it's going to be 7 plus 5 plus 12 plus 15. And once we do that, right, we get a voltage of 19.477, sorry, 744 volts as per the solution here, right? So then again, similarly, we can do exactly the same thing for the second voltage. So we take the supply, times it by 5, because we want at V2 divided by all the resistors. So what I want you guys to do now is find voltage 3 and voltage 3 and voltage, basically, yeah, voltage 3 and voltage 4. Just make this, you just have to correct this. Can you please find this voltage using this new rule that you just learned, the voltage division rule. A very important rule you're going to need to solve circuits. It's like a shortcut of one could say. Sorry about that. And I want you to check something once you're done. Okay, so let me get my V3. Let me get my V4. So what I'm saying again, reiterate again, is that voltage division, we choose the source voltage times by the resistor you want, divided by all the resistance. This is only applicable to series circuits. You notice where this comes in handy. All right. Okay, so what is my V3? So 3.85. You guys agree? What's V4? What is V4? Anyone? Pulling. Hope you guys are working this out. So take the source, 110 times 15, and then we add all the resistance. So 7 plus 5 plus 12 plus 15. So 110 times 15. 42.31, right? Volts. Yes, that's correct. So now my next question is, how do we know that this is correct? If we add all of these guys up, we should get the EMF or the voltage of the battery here. Remember, this is the power source. We cannot exceed the voltage. So if we're going to add all of these up, we should get the total voltage. That's how you can always check if you're correct when you're dealing with a series circuit, for instance. And also it can help you if you're designing an electrical system, you know that that you can't exceed 110. And this is how you, in fact, how you design choosing a system. So if you add these guys up, what you get? I think it's 42.3. Sorry, that looks a bit funny. Yeah. You get 110 volts. Okay. Telling these guys up, you should get 110. Right, so that is the voltage division. Okay, yes, 110. So that is just there for you to confirm, you know. And when you think of electrical systems, it's very important to understand what voltage is. It's just not a number. It's like the maximum potential it has to provide, how much energy it can provide, right? Okay, so Next example, again, here we are just looking at just a quick example on how we're gonna do this. So it's a series circuit. You can see we have a ground here, and I probably want to end up with this example. Continue tomorrow. And the one, the total resistance, so RT, that's going to be the sum of these guys, 2, 1, and 5. That's 8 ohms. Okay, that's good. And on the total current, that's going to be easy. That's going to be 20 divided by 20 divided by 8. What does that give us? 2.5 amps. And the voltage is V1, V2, V3. I'm just going to quickly show you over here at this is now A and B. So remember, this is just revision, but now I'm going to show you using the old school way you probably know. So voltage is current times resistance, and that's going to be for this V1, sorry. So it's 2 times 2.5, and you get 5, of course. That's going to be 5 volts. So it can't be more than that, obviously. So if I use my new technique, V1 is going to be the source times the 1 I want, which is 2, and all the resistance is 2 plus 1 plus 5. So on top here, I get 40, below I get 8, and the bottom I get 5 volts. So you guys see there, it works out. So you guys happy with this new voltage division rule? It's just the extra technique which you guys weren't exposed to. So you might think, why are we doing this? We're doing this because the circuits will get a bit involved. So you're going to need shortcuts for solving. You're not happy with that? Okay, so of course you can follow a similar thing over here. Like I said, this is just very basic examples, and I mean it in all senses. Oh, what's going on now? Yes, okay. So at D, I'd like to know, you guys to remember how to find the power. Seems like my thing is back here. You guys remember how to find the power dissipated. What is power equal to? You guys remember?
Voltage times
Power in
current.
electrical circuit. That's correct. Voltage times current. So we can find the voltage across each one. You'll be able to find the power, right? Okay. So if you look at this here, you can have it as power equals voltage times current. Alternatively, you can have it as I squared R. So that's the electrical power produced by something. So we can try and quickly do this. Our current was 4 amps, right? Okay, so before I actually do this, I just want to, yeah, so we'll do D. So P1 is going to be I squared was 4, if I'm correct. Just can't remember now, 4 squared times 2. That's 16, that's going to be 32 watts. P2 is going to be 4 squared as well. Same current. That's 1. That is 16 watts. P3 is going to be I squared is 4 squared again times 5. 16 and 5. 16 by 5 will give us 18. Right? So if you guys agree with me, that should be the right watts. And then
Yeah, but
P, let's just say, am I out somewhere? What's up?
yeah, our intensity was 2,5.
Oh, sorry, man. The current.
The
Yeah.
current was, yeah.
See, I forgot. We said we adjust all of these values. 2.5 squared times 1. 2.5 squared times 5. That's 12.5 watts with 2.5 squared gives us 6.25 watts. And lastly, we've got 31. So as you can see, what this means is that this guy, this is just he's extracting a lot of power. And if you work at the power of the source, so this is going to be E. So the power of the source is going to be 2.5 times 20. We get 50, right? And just to prove, so what it means, the way I always view voltage, I view voltage as the power source. How much watts am I able to produce depending. And if you see here, if you tally up P1 plus P2 plus P3, what answer do you get? Can you please tell me? What's the answer?
$50.
50 doesn't make sense. You guys happy? Is no one happy? Okay, fantastic. Now to close off, I like to show you something very nice. That's a software called LT Spice. So what I'm going to do, I'm going to reproduce the circuit. So now you can just watch me do this, and then tomorrow we'll continue with the rest of this lecture. But this is also part of the lecture. You have to be able to use the software, right? So I'm gonna open it up quickly. So I'm just gonna open it up. So you can just sit back and watch what I'm doing here. So if ever you want to analyze electrical circuit, and of course softwares are there, things get very complicated. Right? Okay. You can see it. It's a new schematic. So what I'm going to do here, I'm going to start drawing up my circuit. So I'm going to look for my voltage source. This is my voltage source, I think. Yes. Put it over here. I define my what is my voltage source for this question? It was 20, right? And they had no internal resistance. So what I'm going to do here, I'm going to show you some magic here. A resistor over here. Another resistor. I think another resistor over here. Is it here somewhere? Just put it here somewhere. Just gonna escape. Okay. Throw my conductors in. Quickly. Oh. It'll take me less than 2 minutes to do this. That's important in all circuits. Oh, we got a ground him. Got a analog ground, whatever. And now what I'm going to do now, I'm going to define my resistor. So what was my first resistor? You guys remember? Can you please tell me?
Was 1.
2.
Number 1 was 1. Yeah.
And number 3 was 5, right?
5. Yes, sir.
Okay. I got to simulate. I say run. DC. Operating point. Poof. And what do I get there? I get the current 2.5. I get the voltage at, this is at node 3, node 1, node 2. So this is the first node over here. So that's from the reference point till there, 20 volts. Over here, from here to here, I get 15, and from there to there, I get 12.5. So this is what I'm able to do with this software. I could also take my, if I'm right clicking, can you guys see at the bottom there? Right at the bottom. You see the dissipation. Can you guys see it over there? It's at the last line of the software there. At the last, it says dissipation there. Can you guys see it? It says 31.25, 6.25, 12.5, 50 watts. Okay, so yeah, that's the software I like you guys to play around with. I'll post a link after tomorrow's lecture. But what's nice in this software is when the circuits get involved, I'd like you to sketch them and you can verify your answers using your circuit. It's going to help you not only for academic ability, but I'm sure in industry, if you ever have to draw some advanced circuit, I mean, yeah, you can draw very advanced circuits here. Okay, guys, thank you for coming to today's lecture. I'll see you tomorrow morning at 10. Yes, it is very interesting. I can do a lot more, obviously. This is a very basic circuit, so you can imagine including all the other stuff. But thank you, guys. I hope you enjoyed it. Cheers.